Welcome. So this session is about CI/CD, kind of next-gen CI/CD with GitOps and Progressive Delivery. And yeah, I took this picture this morning. What a beautiful city! It's my first time here, and it's pretty awesome. So yeah, cool. So I'm Kevin Dubois. I'm a developer advocate at Red Hat. Been in the software industry about 18 years, mostly writing software, delivering software. And I'm really passionate about improving the developer experience with open source, and open source is really close to my heart, and I'm lucky enough to work at Red Hat where that's all we do, so that's pretty lucky. So you can find me on Twitter, Mastodon, whatever, and I'll post my slides on Twitter as well, so feel free to follow me. I'll share that afterwards. But let's get right into it. So I don't know if you've seen kind of this developer flow with the inner loop and the outer loop. So basically, the concept is, and I'm sure you're well familiar with how it works, the inner loop is where you do your code development, your local testing, some debugging, and so you might have some different cycles of this loop. And then at some point, your code will be, in a pretty good state. You're going to commit it to a feature branch, a main branch, or whatever, and then maybe somebody will review it. A CI pipeline might kick off, and maybe you'll do some security testing, some more integration testing, and then you'll deploy it to probably a testing or staging server, and not directly to production, but hey, I don't know. So that part is basically the outer loop. So you have the inner loop where you're, actually working on your, let's say, on your laptop, developing the code, and then the outer loop where everything outside of your local development cycle happens. And then eventually, ideally at least, you'll go to production with your code, right? So today we're going to focus on the outer loop. The inner loop is pretty interesting too, and I have a talk about that tomorrow, but today we're talking about the outer loop development. And so maybe you've seen something similar to this. So the classic way of deploying or working and developing our applications would be kind of larger monolithic applications, and then we'd have release cycles of maybe every X amount of weeks or months, or in this case, the example is 4 months. But the newer, or the better, perhaps, way of delivering applications where you're getting to market quicker, you get more value from what you're developing, quicker feedback and everything, is of course if you're going to write distributed applications. But of course, that increases the complexity. You can see here all those little tubes are different pipelines that need to be triggered for each one of these distributed applications, whether you call them microservices or not. And then they might even have their own databases and everything. So you need to have a different way of delivering your applications, right? So CI/CD, of course, can help with that. So you will build your code, you'll do some testing, maybe some security testing, and then you'll have your code kind of built and ready to go. And that part is, part of the continuous integration, as I'm sure most of you are familiar with. And then you'll deploy to staging and production in some way. And so, that continuous cycle is called the continuous delivery and continuous deployment. The main difference between the two being with continuous delivery, you continuously, you have a cycle where you're developing your code, you're testing it, you're building it, and getting it ready for production, but you still have a manual, kind of button or process before you actually go to production. And this is the most typical scenario. But you can actually, go a little bit further and say, if my tests are good enough, if I have enough faith in the process, maybe we can automatically deliver our applications on a continuous cycle. So we're going to start this session with the continuous delivery of a little game that my team and I have developed. And the UI is definitely not me, because I'm terrible at UI, but One of my colleagues did that. So basically, we're going to play this game, and so you're all going to participate. Ideally, if you have a cell phone and enough internet. So we're going to do a little car race game, and so we have these two cars there, and so you're going to be randomly divided into two teams. And on your phone, you're going to see what's on the left there is a wind turbine. And so basically, you're going to create, wind energy to power these cars. And so we're going to do that by tapping on our phone, and that's going to generate a little windmill to create energy for our cars. Okay, so I hope you're you're ready for this. So the architecture of this game, real quick. So basically, when you sign up or when you go to the QR code, I'll share that in the next slide. You're going to get a random player name assigned. We're going to save that in in-memory database, data grid database. And the application is a Quarkus application. Who here is, let's say, a Java developer? Okay, so there's a few. That's good. And so Quarkus is the runtime that I'm using here. Quarkus is a newer Java framework that starts up super fast, has a really nice developer experience. And so it's nice in this case because we're going to scale from one game to the other, and so it starts up really fast and is very performant. So it's a great candidate for this. So basically, when you tap on your phone, you're going to generate power by basically calling a REST endpoint that's going to create events that are going to be sent to a Kafka. And then the dashboard that I will have on my laptop will receive these events, and that's how the little cars are going forward. So who's ready to play a game? Scan the QR code, and then we'll go to the dashboard. So if everything goes well, you should see the little car kind of spinning, waiting for game. And then once that's ready, I'll go to my dashboard, and we're gonna start the game. So if everybody's ready, I'm trying to see if people are still. No, one more second. All right. If anybody still wants the QR code, we'll play the game again in a little bit with a different version, okay? But so for now, I have my game here. Let's go to the dashboard right here. And if everybody's ready, I'm going to start the game. And then, so basically, just tap on your phone, and then the cars are going to move. Everybody ready? 3, 2, 1. Oh, wait, I need to refresh because, oh, there it is. Okay, so go ahead and tap as fast as you can, and we'll see who's the best tapper. We'll see which user is going to prevail. Got a pretty close race here. Team 1 is going to win unless Team 2 really pulls it together. All right, Team 1. Good job, Team 1. And who has the username Macus? They're just randomly generated name. Do we have a Macus in the room? I hope so, because that would be really weird if not. Okay, maybe Macus is a little shy, or I'm not seeing him. Anyway, good job. So why am I showing you this game? Because of course we're gonna release a new version of this game, right? So what if we added a new feature to this game? So tapping is fun and all, but it's not really realistic when we're trying to mimic this wind turbine. We need some more movement or something. So actually, let's create a new feature where instead of tapping, we're gonna shake our phone to make the cars move. Okay? So are you ready for my code development? Yeah? All right, let's do it. So here I have my code repository, and I'm just in GitHub, and I'm just gonna do all my development in GitHub, and I'm gonna change tapping to false and shaking to true. And that's all my development, because I already have it built as just a feature flag. All right, so I'm going to commit this change straight to the main branch. Why not? I'm going to say enable shaking. Okay, I'm going to commit my change. And so I've made my code change. Let's pretend that I went through that whole inner loop cycle of developing and testing and all that, and then we did a code review, right? Sure. And so I have a hook, a webhook that every time there's a code change in my GitHub is going to call a pipeline that's going to kick off. So here we're going to see this is an OpenShift instance, which is kind of a Kubernetes flavor, and we can see here my pipeline has started. So I'm going to go back to the slides for a little bit and explain a little bit more about this, and then we'll go take a look at that again. So we're at our new feature. Well, today is not Friday, but let's say, as a real developer, I'm doing my code changes and I commit on a Friday afternoon, and I'm telling, hey, ops, develop or deploy my feature. It's ready to go. And ops is like, seriously, on a Friday afternoon? Come on. But actually, and this is of course what happens then, right? When you implement a new feature, especially on a Friday night. So if we go back to that developer flow, so I was developing my code and everything, and then we had our code review. So a better way to deliver our application, instead of saying, hey, ops, deliver my application here, throw it over the wall, like admittedly I used to do as well in the past. What if we can automate this and make this into a process where we can actually deliver our code no matter when, and have confidence that everything is going to be, okay or reasonably okay. So if we follow this kind of outer loop cycle, well, first of all, we need to have enough confidence in our CI, in our continuous integration cycle. So let's make sure that we have our testing and all that. And then in terms of deployment, instead of relying on manual processes, let's rely on more automated and more a system where we can actually have more confidence in. So this was supposed to be before, because I already did my live coding, but the other part is definitely true. I have no idea what I'm doing. So the first part that happened, right, I made my code change, and then I did a git commit to my main branch, and that kicked off a pipeline. And so the pipeline, the CI process that I was using, or that I am using, is Tekton. Tekton is pretty cool, especially if you're working with Kubernetes, because it uses, it's totally Kubernetes native, and it uses serverless in the background. So that means that I can define my pipelines in code, and basically when I kick off a pipeline, it's going to read my my definition, and it's going to we have different tasks in there, and it's going to run one task or multiple at the same time, but it's going to run them in a container, run them spin up a container, run them, and then scale back that container to 0. So you're not actually using resources. For those who are maybe familiar with, let's say, a Jenkins or something, well, it's quite a beefy kind of server, and then you have to manage it and configure it and all that. So there's none of that with Tekton, which is pretty nice. You just have some definitions of what a pipeline should look like, and then everything happens automatically. So in this case, we can see one of those pipelines. So if we go to a pipeline, you have a pipeline run as the actual implementation of an actual pipeline, and we can see here that it's already done its job. So it did a git clone, and then did a Maven build in this case, because it's a Java application. Then it built a container image with Builda, and then it updated it updated the manifest of my deployment. And so basically I have two repositories. So I have the one that I already showed you with the source code of the game, which you're free to go to as well. I'll share the link afterwards. But I also have a Quinoa wind turbine manifests. And the manifests folder contains our Kubernetes manifest. It contains the Tekton manifests that define how the pipeline should run and what tasks it should do. And so basically, when I pushed my container to the registry, it updated my value here in a customization file. And this customization file, if you're familiar with Kubernetes, customize is a way to well, configure some of your manifests in a more dynamic way. But so what it did, and you can see here 2 minutes ago, it updated the image digest. And you can see here, in this case, I updated the value of my own Quinoa wind turbine container, and it updated the tag of the image. And so by doing that, and by updating this value, I triggered another process in GitOps. So if we go back to the slides, I'll tell you all about GitOps. Who's already familiar with GitOps, or let's say somewhat familiar? Okay, this is good, because that means that most people are maybe still going to believe what I say. No, I'm just kidding. So what is GitOps? So essentially, you use Git as a single source of truth, not just for your source code, but also for your deployments, for your configurations, for basically anything in a Kubernetes world. So you can even configure your entire cluster, have all the manifests stored in your Git repository, and use that as your single source of truth. And then use that to, when your source code, your source manifest change, to automatically change what's in your cluster. So it's going to automatically update your cluster to match with what you have defined in your manifests. So you're going to basically treat everything as code, and then use your typical Git flow operations also for your infrastructure definitions and everything. So in the application delivery model that I'm using today, that's exactly what's happening. So I have the source code of the game, then we went through a continuous integration pipeline, and then I pushed to an image registry that created a commit in my other repository, where I have the definition of the Kubernetes deployment and the service and all that. And then GitOps, and in my case, I'm using Argo CD, is going to see, hey, there's a change to what your desired state is, what you've defined in that code is what my cluster should be like. And I'm seeing that my cluster is not the desired state, it's still in the previous state. So it's going to automatically update that value and pull down a new image and a new version of our game in Kubernetes. So let's take a look real quick at how that works. So I have, and I see my cluster tab has disappeared. Let's see if I can find it again. I think it's this one. Must have accidentally closed it. So let's wait for the internet to work with us. And blah, blah, blah. There we go. Okay, so here's our pipeline that we saw. So here we can see the game that is deployed on this Kubernetes cluster, on this OpenShift cluster. And you can see here, well, it's already scaled the new version. And we can see that because we have our Argo CD cluster with the GitOps running right here. And if that one doesn't work quickly enough, I have another tab here. So this is basically all those manifests that I've already defined. And so Argo CD is keeping an eye on those. And actually, let's refresh and then see if it picks up the changes. This is a different application. Let's go back to the game. Wind turbine. Okay. So here we can see that it synced 4 minutes ago. So if I refresh, it's probably not going to do anything because it already did all its work. So 4 minutes ago, what it did was it tore down the previous containers, well, and deploy new versions, new containers with the new version. And so it did that, kind of in a gradual basis, so that our new versions were deployed first, and then it would, flip the traffic to my other version. So if we go back to our slideshow here, let's play the game again. And if everything went well, you should see this enable shaking this time. And so if you tap on that, well, then shaking should be enabled. So is that what everybody's seeing? Because Yes? I'll try to play as well. So this time we're going to shake our phone instead of tapping it. And I would say people be really careful. Hold on to your phone because I don't want anybody getting hurt or me, like all of a sudden this phone flying around. So if everybody's ready, let's play the game again. So now we've delivered our new application. So we did that pretty fast, right? So we went through all our coding that I did, and we went through a CI pipeline. We did our testing, security scans, whatever, and deployed our new feature all automatically because I did a git commit and pushed, of course. So let's play the game again. Let's go back to here and refresh this real quick. And of course, I have a new version. I need to log back in. Okay, so we have 43 players in team 1 and 44 and 40 in team 2. Now, it doesn't matter how many people are in team 1 or 2, is just the average that it uses for each team. But that also means, like, if you have it on your phone, you have to play, okay? Because otherwise you're holding your team back, okay? We don't want to be that guy, right? Okay, so if everybody's ready, 3, 2, 1, go. Okay. Shake harder, team 2, come on. Come on, team 2. Oh, this is another close race, but team 1 won again. So who's Holly? Nice. Well, I'll get you a beer later on. Good job. All right, so that's a way to deliver an application with Argo CD and GitOps. So now, of course, in my title, I had progressive delivery. So what's the difference then between what we've already done and progressive delivery, and how can we make it even better and more, have more confidence? Because in this case, what I did was I committed my code and it did everything, and what it did was, one version flip to the next version. So all my traffic went to the new version, which means that if there was a bug in my newer version, that all my users would be affected at the same time, and I'd have some massive downtime. So instead, what if we could do progressive delivery and do step-by-step delivery of our application? So what is progressive delivery? So it uses, of course, all the same kind of continuous integration, continuous delivery, but the continuous deployment is something that we can refine a little bit more. So progressive delivery, what does it mean? It means there's no big bang release. There's not just, version 1 to version 2. We're gonna, do it gradually. But basically means that a deploy doesn't necessarily mean a release. So when we deploy to production, it doesn't necessarily mean that our users are gonna be using it. So we're gonna rely on metrics to see how is my application behaving. Are there certain errors that are happening sporadically, maybe across the board or not? And let's monitor that, and based on that, let's either roll it out further or roll it back. And so we can do rollouts, releases to subsets of users instead of the entire user base at once. So I think it's probably already kind of obvious why you would want to use progressive delivery. Well, first of all, to decrease downtime, because you don't have everybody affected at the same time if there's an issue with your new version. And so it limits the tragedy of the release, and especially on that Friday night, if all of a sudden you have a big downtime and you had big plans to go have some beers with our friends that won our little game, that that would not be so fun. So we limit the tragedy, and we can deploy and release to production faster because we have more confidence in what we're releasing, and we have more confidence in how we're releasing. So we can release to a subset of users, a small percentage, and if something goes wrong, we can roll back, and it doesn't affect everybody. And so it also means that we can test on production. And so we need to do less mocking of our services and less setting up, kind of, let's say, unreliable fake services where we're trying to mimic how it would behave on production without really knowing how it's going to work on production. So I was at this conference a few weeks ago, and I thought, that's a pretty good example of why we might want to do that, right? Because you can do lots of mocking of our dependencies and everything, but at the same time, at some point, you're making your mocking more complex than your actual application, and that's what Victor here was saying. They have a production code that has 4 lines, and then the test was more than 20 lines full of mocks, and it gets way worse than that. So you got to kind of balance whether it's worth it to do mocking at that point, right? Maybe it's better to just actually test on production. So there's different ways of doing delivery, and so let's walk through a few of those delivery techniques. So the first one, which is pretty common, pretty well known, is the blue-green deployment, and that's basically all or nothing, right? So you have your version 1, you're deploying a version 2, you're flipping your traffic to version 2, and then you can still roll back, which is good. You don't have the tragedy of, well, we've deployed our new version and we have no idea how to roll back, so now we're going to have to go on production and live trying to debug and make changes. So blue-green helps, definitely helps with that, but it's an all or nothing situation, which sometimes you may need to do, right? If you have stateful services where you have a database that also changed the version, you need more of a rollback plan than just saying I'm going to roll back my application. But aside from that, it works pretty well. Canary releases, on the other hand, allow you to be a lot more fine-grained with how you're doing your deployments. So instead of saying we're going to flip our traffic from one version to the other, we can say, hey, we're going to start with 10%, send 10% of our traffic to our new version, and then kind of seeing, depending on metrics, whether we want to increase that percentage until eventually perhaps we have 100% of our traffic. Then there's also dark launches that you could do. The dark launches are interesting because it mirrors your traffic potentially between your 2 versions. So you have version 1 that you're still using, you release version 2, and then you're going to send the traffic to both versions at the same time, but your user is only going to see the traffic of version 1. So you're just basically cloning, duplicating your traffic to the V2, and then seeing how it behaves under real production load and production usage. And you can also use feature flags. So it can be just dark launches, mirroring traffic, or you can say, hey, if there's a specific feature flag, if there's a certain user agent or something, they're going to be using version 2, so we can have maybe somebody in our organization testing the new version. So that's an option too. So basically, it allows us to use to test on production. So maybe don't tell your boss that you're doing that. They're usually not very happy with that. But actually, it makes a lot of sense. Depending on the scenario, of course. There's always scenarios where maybe it's not a good idea, especially if you're affecting your production database. But I would recommend to think about that and find ways around that. So in terms of the testing pyramid, those who are familiar with the testing pyramid, most of your tests should be unit tests and local tests and component tests and blah, blah, blah. Of course, this does not look like a pyramid at all, but it's the new testing pyramid where we're doing some testing on production. For example, we can do certain integration tests when we're deploying, and while we're releasing, we can do the canaries, the dark canaries, doing some monitoring, feature flagging, and then after release, keep on testing, doing the monitoring, A/B testing or whatever, to potentially roll back if we need to. So how do we accomplish progressive delivery Well, it's a lot easier with Kubernetes, so we're going to use that for the rest of the session, and I guess we've already been using that in this session. So Kubernetes makes it a lot easier to do, these kinds of deployments, right? So blue-green you can do with Kubernetes. You don't need anything really else. In addition to Kubernetes, Kubernetes is able to handle that. So you have, we're going to see a bit of YAML for the rest of the session because, of course, it's Kubernetes, right? So we have our blue-green service here. So we have a service, and basically we have a selector with an in-service with a name that matches with a label of a deployment, and that's how we can deploy a new deployment, have it with a different label perhaps, and then our service, we update that selector to point to the new service, and that's how we can flip traffic. And then if we want to roll back, we just change that selector back. So that's the way to do it with Kubernetes. You can do canary releases with Kubernetes, but it's a little bit, I would say, annoying, and it's definitely a manual process, but you can do it. I mean, you can automate it in some way. But basically what you would do is you have two deployments, and then you can say, hey, I have my version 1, and I have 3 instances, 3 pods running of that deployment, and then I'm gonna have my version 2 with 1 replica, and then have my service point to both these deployments at the same time. And so basically you can split your traffic that way. But what's an easier way is if you use something like a service mesh to have more fine-grained control over your deployments. So with service mesh, you get a lot more control over the traffic and the networking of your application. So it can do things like intelligent routing, load balancing. So you can do canary releases more easily. It can do dark launches, which I would have no idea how to do that with just Kubernetes. To do, like the traffic mirroring, or based on user agents or some other parameter. What's also cool with service mesh is that you can do, for example, fault injection. You can say, hey, in 5% of my traffic, I want to inject some sort of error code to see how it actually is behaving if an issue occurs. So that's kind of the idea with chaos testing, is that you have a way to test if something goes wrong without something actually going wrong. So you have a lot more confidence instead of waiting for that day when something does go wrong. And if you do that kind of on a continuous basis, it works pretty well. So you're able to handle mistakes a lot more. So that's something that you can do with service mesh. You can use circuit breakers and add telemetry more easily, and so on and so forth. But we're not going to go into that too much in this session. Just to give you an idea, so Istio is an implementation of the service mesh pattern. And so Istio, the way that it works, it has a control plane where you can configure how your services should behave, how they should be scaling or routing traffic and everything. And then for every pod that you're deploying, it'll insert a little sidecar container in that pod that's going to externalize the traffic. So that's kind of how it works without going into too much detail. So it uses a sidecar that intercepts the traffic of the other container that's running in that pod to basically handle all that stuff. So canary releases with Istio, again, YAML of course, but you can see here, you can set a route destination for version 1, and you can set the weight. So that's out of 100, so that's 75% of my traffic would go to my version 1, and then you can see my version 2, we're going to send 25% or whatever you want to do, right? So it makes it a lot easier to do canary releases. And then same with shadowing traffic. So you would set, mirror to version 2, and that's how it would mirror your traffic. So quite easily you can configure how to do those releases. And then, for example, also the dark canary, where you set, if the end user in my header equals Alexandra, only Alexandra gets to test version 2, and then we'll see what Alexandra says. And so you can have different ways of doing that. So that's with Istio. But so for now, this is still kind of a manual process, right? Because you have to change the files and then commit them, and then, you know, of course, GitOps and Argo CD or Flux, if you're using Flux CD, will mitigate and change those values. But you know, there's still kind of a manual process involved in scaling your traffic, especially if in this case, well, how do you go from 25% to 50%? Well, every time that's a commit, that's something that you would do then on that Friday night, and so, you know, that's still somebody that has to do that. So, you know, what if we can automate this more? And that's where yet another project comes into play. So Argo Rollouts is done, you know, kind of with by the same community as the Argo CD community, but it is not Argo CD, it's Argo Rollouts. It's a different project under that same umbrella. But what Argo Rollouts allows you to do is, well, work with Argo CD, but you can have it monitor, well, your metrics to see how everything is going, and then automatically, step by step, do your rollouts. And so you can use, you know, Prometheus, or, well, in this case, there's Datadog on there. There's a bunch more vendors that you could use. Prometheus is open source community, so that's what I like. But you can use whatever, and then Istio as a service mesh, or you can use Nginx or Traffic to you know, report those metrics that are then being looked at by Argo Rollouts to decide whether it should roll out further or not. So basically, this is the way it works. So yes, more YAML. So you can define a rollout strategy where you would say, hey, we're going to have different steps. And so our first step is we're going to set the weight, the percentage of traffic, to 20%. We have the duration of 1 minute. So, you know, after 1 minute, if everything goes well, we'll go to the next weight, which is 50, and then we're going to wait 2 minutes, see how it works, and then keep rolling out. Now, in reality, you might not want to do it, you know, with such short intervals. You would probably use more time to collect more metrics, to have more insight. You might start with a short interval to see, you know, if anything is really bad, then to roll back. But so that allows you to automate things a lot easier. But you're still, in this case, you're responsible of looking at the metrics and manually, you know, saying stop to this automated rollout and roll it back. So, you know, what if we can do this, what I call smart progressive delivery, based on metrics, and have everything kind of go automatically. It's going to look at the metrics to see how is the rollout going, are there, you know, certain types of errors that we're looking for, and if so, then roll back automatically. And so you can do that with the same Argo rollouts. You can add an analysis template to it, which, you know, if you look at the template name, that's success rate, and so then I have an analysis template that matches, of course, with that name. I have an interval which says every 10 seconds, check if my success condition is true. And then the success condition is basically, in this case, from a provider, Prometheus, where I'm saying, look at, you know, my service, if there are any 505 whatever errors, and if so, over the last 30 seconds, and if so, then after 2 failures, roll back. So you can be very fine-grained about how you're doing your deliveries. So we're going to try to show that in a live demo. Now, this one's a little tricky because it depends on metrics that it's generating as I'm deploying it, and I need to have enough metrics to collect, and so we'll see how it goes. But it's not a guarantee if it's going to work, because you know, I'm not smart enough to have it reliable enough. But so I have this other application. Sorry, no more car games in this case. So I basically just have some random bubbles that are being generated. So, and they're blue color. And so I'm gonna release a new feature, which is basically gonna change the color from blue to green. And so git commit. Change to green, git push. Okay, and so now this is also an application that I have in my Argo CD. So if we go look at it, there's a Bubbles backend, and let's refresh this real quick. And it's gonna see, oh, something was changed, right? I made a commit, and so it's gonna automatically release this new feature. But so because I have, in this case, my progressive delivery defined with an analysis template, this is very small, but that's gonna monitor how the release is going and if there are any errors that is producing. So in my Prometheus here, nobody should be able to really read this, but this is basically the same query that this analysis template is running automatically. So let's take a look and see how our rollout is going. So there's our Argo Rollouts. And so what you can see here is that it's creating new containers. So at the bottom you can see revision 1, and we have a certain amount of pods. And you can see at the top it's creating new pods, and then you see that analysis run, which is running every 20 seconds or whatever to see if everything is going well. So it looks like 7 times it was positive, there were no errors, and so it keeps rolling out gradually more pods until at some point everything is going well, because I have it set for maximum 2 failures, and we only had 1 failure. And so you can see that with a delay of 7 seconds here, my first revision is going to scale down to 0, and all the traffic is at this point being pointed to my new version. So in this case, our rollout was successful, and you can see terminating and scale down. So version 1 is done. Because we looked at the metrics, everything was going well, and we scaled, and we sent our traffic to version 2. Now, this was a really fast demo, right? In reality, you're probably going to want to do this a little more slowly. But let's see if we now release a bad version. And so I have another image that's going to create some errors occasionally. And then we'll see if our rollout is going to, in this case, not work. So we're going to, let's say I developed my code changes and went through the CI pipeline, and I pushed my image, and I updated my digest, and now Argo CD is going to pick that up. Let's pretend that all happened. And so we're going to push our changes, and then in Argo CD again, in our GitOps, we're going to refresh one more time. It's going to say, oh, there's a new change again. Let's try to roll it out. And so we can see here, 2 pods are created, and we're going to give it a little bit of time. I think I gave it a delay of 25 seconds. And after that, it's going to start running the analysis based on the metrics that my application is generating. So my application here with the bubbles, which I've changed color in the meantime to green, right? But so the yellow button, the yellow bubbles are the new version that I'm releasing. And yellow basically means it's there are errors. And so let's see what happens. So we have 2 times the 2, you see the x2. So 2 times already in our metrics we're seeing errors. And so if we have 1 more time that we're seeing errors in our metrics over the last few seconds, then which just happened, then our release failed, and we're going to roll back automatically. We're going to send our traffic immediately back to our previous version. So if we look here, we don't see any more yellow bubbles. So we only see green bubbles because it rolled back to our previous version. And you can see here our status is degraded, and at some point after our delay here, it's going to scale back down the new version because it says it's no good. You need to retry and release it in a new version. And so that's what happened. And so that's how you have a lot more control over how your releases are going, using metrics, using some cool technology in Kubernetes. And so that was the demo about that. So some final notes since we're at the end of our time here. So like I said before, this is relatively easy to do when you have stateless applications. When you have stateful applications, of course, you need to think little bit more about, how is that going to affect my data if I have traffic mirroring or if I'm rolling out between different versions and everything. So think about that. Do it step by step. Definitely embrace GitOps. Have your single source of truth, which means that, I know exactly who made a change on the cluster. I know when it was made. I know what was changed, and I can roll back very easily. And if somebody goes onto the cluster and makes some manual changes, maybe, in the middle of the night they wanted to change something, GitOps is going to see that and say, hey, that's not in sync with what we have defined as the single source of truth. And then you can decide whether you want to automatically mitigate that or do it manually. That's up to you, of course. And so basically, if you haven't automatically destroyed something by mistake, then you're not automating enough. So, of course, that does happen. There's the links for some of the demos, and yeah. So the OpenShift Kubernetes that I was showing, so you can use it for free, which is kind of cool, I think. So you can get a free instance of the OpenShift sandbox for 30 days, I think. Then you have to renew it, but that's something that I usually use in my demos as well. If you want to learn more about GitOps, my colleagues Natalia and Alex wrote a book about that, and you can download it for free from the Red Hat developers. I think, just create a free account, which I think you need to create for the OpenShift sandbox too. And then, yeah, here's some more resources. I'll share the slides on Twitter. And also, if you're a Java developer, this is a cool book also by my colleagues, Marcus and Natalie. So there's a free download for that book too. And with that, I thank you. So again, thank you. If you like this, definitely follow me and let me know what you think. I know this is a lot of information in a short session, but I'd love to hear your feedback. Yeah, and if not, I'm available here after the session as well. So thank you.